In this section, we're going to talk about how we can interpret and use the slope in equations, graphs, and tables. Now previously we have already mentioned that when an equation is in the form y equals mx plus b, it represents a straight line. And in fact, this particular form of an equation of a line is called the slope-intercept form of the equation of the line. And the reason it's called that is because both the slope and the y-intercept are right in the equation. M represents the slope of the line, and the letter B represents the y-intercept of the line. Now technically the y-intercept is the ordered pair 0, comma b, but that letter B tells us where the line crosses the y-axis. Now we've already gone over a way of graphing lines by making a table of ordered pairs and plotting points. But there's another way you can graph a line using the slope and the y-intercept, and I'd like to show that to you now. Suppose we were given the equation of the line y equals negative 1/3 x plus 2. Well, since this is already in the form y equals mx plus b, we can tell what m and b are just by looking at the equation. In this case, m, or the slope, is negative 1/3. Now remember, when the slope is negative, it's best to put the negative sign in the numerator of the fraction. So we'd have negative 1/3. And also, the y-intercept can be found by using this number. And so the y-intercept would be 0, comma 2. Okay, now let's see how we can use this information to graph the line. We'll start with the y-intercept, 0, comma 2, and we'll plot that point on the graph. Notice that this point is right here on the y-axis. Now we'll interpret the slope as a rise over a run. Now the slope is negative 1/3. That means we should go down 1 and to the right 3. So starting from this y-intercept right here, we're going to go down 1 and to the right 3. And we can do this several times if we want. So we can go down 1 and then to the right 3, and then down 1 again and to the right 3 again, and then down 1 again and to the right 3. And we can keep doing that as many times as we want. And that will produce a sequence of points that are also on the line. So we'll plot those points. And once we've plotted those points, we can just connect them with a straight line. Okay, let's try this again for another example. This time we would like to graph the line 2 times quantity y minus 3x equals 8. Now the problem here is the line is not in the form y equals mx plus b, and we'd like it to be in that form. So we'll first do some algebra to put it in the form y equals mx plus b. Now the first step would be to distribute the 2 through the parentheses, which would give us 2y minus 6x equals 8. Now remember, we're trying to put it in the form y equals mx plus b, which means we have to isolate the y, meaning get y alone. Before we can do that, we have to isolate the term that contains y, which is 2y. So our first goal would be to get the term 2y to be alone. So in order to do that, we'll add 6x to both sides. That gives us 2y equals Now we could either say 8 plus 6x, or we could say 6x plus 8. I'm going to say 6x plus 8 because I'm trying to get it into the form y equals mx plus b. The last step would be to divide through by 2. We'll divide each term by 2, which gives us y equals 3x plus 4. So now the equation is in the form y equals mx plus b. And we can see that m would be 3. So we'll write that down, m equals 3. Now we'd like the slope to be a fraction so that we can view it as being a rise over a run. So when it's a whole number like 3, we'll write it as a fraction by putting it over 1. So it's 3 over 1. And then this number 4 gives us the y-intercept. So the y-intercept would be 0, 4. So again, how do we graph this line? Well, we always start with the y-intercept. So we'll plot that right on the y-axis. Okay, so you see I've plotted that right here on the y-axis at the point 0, 4. The next step is to interpret the slope. Now the slope is 3 over 1. That's a rise over a run. That means we want to rise 3 and go to the right by 1. And we're always going to start at this y-intercept to do that. So starting from the y-intercept, I'll move up 3 and go to the right by 1. And then I'll do it again. I'll go up 3 and to the right by 1. And that gives me 2 other points on the graph, which I can then plot. Now if we wanted to plot some points in the other direction, we'd have to reverse the pattern and go down 3 and to the left 1. So I'll do that a few times. Down 3 to the left 1, down 3 to the left 1, down 3 to the left 1, down 3 to the left 1. And that would give us even more points along the graph. Then all we have to do is connect the points to graph the line. Now let's try a little bit different problem. This time we're given the graph of the line and we have to try to find the equation of the line. Now we know the equation of the line will take on the form y equals mx plus b. And we know that because it's a straight line, and any straight line can be written in that form. So all we have to do is figure out what is the m, which would be the slope, and what is the b, which would be the y-intercept. Now, let's start with the y-intercept. The y-intercept should be pretty easy to find because all we have to do is look at the graph and see where the line crosses the y-axis. Now this is the y-axis right here, and we're looking for where the line crosses it. So it crosses right there, and you can see that's at 5. So therefore b is going to equal 5. Now we have to determine the slope. So now this is a little trickier, but still not too bad. Starting from that point 5 on the y-axis, we have to try to figure out how far down and over do we go until we come to another point on the line. Now it looks, if we look at this carefully, it looks like if we start at that 5 and we go down 3 and over 1, it brings us to another point on that line. Now if that's correct, we ought to be able to keep doing that over and over again. So down 3 over 1, down 3 over 1, down 3 over 1, down 3 over 1. So sure enough, it looks like the slope is down 3 for the rise, which would be -3, and 1 for the run. So the slope should be -3 over 1. So when we write this equation down, the answer would be y equals -3x plus 5. In this next example, we're given the equations of two lines and asked to find if these lines are parallel, perpendicular, or neither. Recall from the last section that parallel lines have the same slope and perpendicular lines have slopes that are negative reciprocals. So we need to start by finding the slope of each line. This can be done by changing them into the form y equals mx plus b and then seeing what the slope is. Let's start with the equation on the left. We're trying to solve for y, so we'll start by subtracting 5x from both sides. That will give us -3y equals -5x plus 1. And then we'll divide everything by -3. And whenever you have a negative divided by another negative, the answer is positive. So we'll get y equals positive 5/3 x minus 1/3. So the slope of this line is 5/3. Now let's do the same thing for the other equation. We'll subtract 3x from both sides. So that will give us 5y equals -3x minus 2. And then we'll divide everything by 5. And so the equation ends up being y equals -3/5 x minus 2/5. And the slope of this line is -3/5. Now if we compare the two slopes, we notice that they're negative reciprocals of each other because one's positive and the other's negative, and they're also reciprocals, meaning the fraction is flipped. Therefore, we can conclude that these lines are perpendicular. Now I'd like to look at linear relationships from a table perspective. Now, if two variables are linearly related, meaning they follow a straight line, then if x changes by a consistent amount, then so does y. Now, in this table, we have 4 different sets of data, and we're going to look at each one at a time and determine if those sets of data represent a straight line or not. So let's look at set 1. Now first of all, we have to determine, does x go up by a consistent amount? It goes from 1 to 2 to 3 to 4 to 5 to 6. So certainly it does. X goes up by 1 each time. So in order for this to be a linear relationship, y would also need to go up by a consistent amount each time. So from 6 to 106, it went up by 100. And then from 106 to 205, it looks like it only went up by 99. And then it went up by 100 again. And then it went up by 101. So you can see that y is not going up by a consistent amount each time, even though x is. So that shows that this is not a straight line. It's not a linear relationship. Now let's look at set number 2. Now again, x appears to go up from 1 to 2 to 3 to 4 to 5 to 6. So that goes up by a consistent amount of 1 each time. Let's look at what happens to y. Y goes from 5.9 to 5.6. So it went down by 0.3. And then it goes to 5.3. So it went down 0.3 again. And then it goes down 0.3 again to 5.0. And then down 0.3 again, and then down 0.3 again. So this is a linear relationship, because as x goes up by 1 each time, y goes down by 0.3 each time. Now let's look at set 3. Again, let's start with the x. X goes from 1 up to 11, so it went up by 10. And then it went to only up by 2, and then it went by 7, and then 20, and then 50. It's jumping all over the place. Whereas y goes from 3 to 8 to 13, so it looks like it's going up 5 each time. So in this case, we can see that y does follow a consistent pattern, but x doesn't. So this is not linear. And then in this last set, set 4, x goes from 50 to 51 to 52, 53, 54, 55. So that goes up by 1 each time. Y starts at 90 and goes down by 10, and then by 10 again, down by 10, down by 10, down by 10. So that looks like it's linear, because every time x goes up by 1, y goes down by 10, and that's consistent. Now let's look at a different example. In this case, we're going to assume that x and y are linearly related. So we're going to assume that they follow a straight line. And we have to fill in the blanks. So let's start with equation number 1. Now remember, every time x goes up by a consistent amount, y needs to also go up or down by a consistent amount. So in this case, x goes up by 1 each time, and in the first case, y goes from 16 to 23. So it went up by 7. So it's going to have to go up by 7 again, and again, and again, and again, in order for it to follow a linear pattern. So 23 plus 7 would be 30. And then 30 plus 7 would be 37, and then 37 plus 7 is 44, and 44 plus 7 is 51. Okay, now let's look at equation 2. Now in this case, again, x goes up by 1 each time. And so y is going to have to follow some consistent pattern. Now all we know is that when x is 3, y is 6, and when x is 5, y is 14. So when x changed from 3 to 5, meaning it went up by 2, y changed from 6 to 14, meaning it went up by 8. So the slope would be y2 minus y1, so 14 minus 6, divided by x2 minus x1, which would be 5 minus 3. So that would be 8 over 2, which would be reduced down to 4 over 1, or just 4. But when you look at it as 4 over 1, that shows you that the y changes by 4 every time the x changes by 1. So every time you go up 1 on your x, your y should change by 4. So for example, when you go from a 6, this next one here should be 4 more, which would be 10. And then when you go from 10 to the next one, it would be 4 more. Okay, which it is, 14. We can also go backwards. If we're going backwards, we're going down by 4 or subtracting 4. So this one right here before the 6 should be a 2. And then if we go down 4 again, we'd be at negative 2. And then -6. In equation 3, we have a similar situation. Only 2 rows are filled in. And so I think it would be smart to calculate the slope again. So that in this case the slope would be 16 minus 36 divided by 6 minus 1, which comes out to be -20 over 5, which reduces down to be -4 over 1. Now when we look at the reduced form of the slope, -4 over 1, that tells us the rise is -4, meaning the y value goes down by 4 every time the x value goes up by 1. So this is a rise over a run. So the y goes down by 4 when the x goes up by 1. So if we follow that pattern, every time the x goes up by 1 here, the y should go down by 4. So we'll do 36 minus 4, which would be 32, and then minus 4 again, which would be 28, and then minus 4 again, which would be 24, and then 20, and then minus 4 again would bring us to 16. So we know that's correct. In this last example, we have a similar situation, so we'll do the same thing. The slope would be y2 minus y1. So let's think of this as y2 because it's the later point in the table, and that's y1. So we'll take 70 minus 80, and that's going to be over x2 minus x1, 14 minus 10. So we have 70 minus 80 divided by 14 minus 10. That comes out to be -10 divided by 4. Now I'd really like the denominator to be 1, so I'm going to divide the top and bottom by 4. So it's -2.5 over 1. When I look at it that way, again, that's a rise over a run. That means the y value is going to go down by 2.5 every time the x value goes up by 1. And we can see in this table the x value is going up by 1 each time. So the y value should be going down by 2.5 each time. So when we fill these in, we would have 80 minus 2.5 would be 77.5, and then if we subtract 2.5 again, we have 75, and then 72.5, and then 70, which is already filled in, and then 67.5. The last thing I'd like to go over today is something called the slope addition property. And what this property says is that if x increases by 1, then y changes by whatever the slope is. So every time, this assumes you have a linear relationship, that every time x goes up by 1, y is going to change by some consistent amount, as we talked about before. And that consistent amount equals the slope. So every time x goes up by 1, y changes by the slope. Now if the slope is positive, that means y goes up by that amount. And if the slope is negative, it means it goes down by that amount. So for example, let's look at the application here. It says let y be a college's enrollment in thousands of students, and let x be the number of years that the college has been open. Assume that the equation y equals 0.5x plus 6 describes the relationship between x and y. So that clearly is a linear relationship because it's in the form y equals mx plus b. So it will follow this slope addition property. So this is actually quite simple because you can see here in the table x is going up by 1 each time. And according to the slope addition property, every time x goes up by 1, what's going to happen to y? Well, it's going to change by whatever the slope is, 0.5. And since that's a positive number, it means it's going to go up by 0.5. Now, we have to find what the initial starting point is, though. So when x is 0, we need to find out what y is so we have something to base everything else off of. So when x is 0, if you plug a 0 into your equation here for x, you'd see that y comes out to just be 6, which is the y-intercept. So we know the y-intercept would be 6. And then, once we have that starting point, we'll use this property. Since x is going up by 1 each time, this y is going to change by the slope, meaning it's going to go up by 0.5 each time. So if it's already at 6, then the next one's going to be 6.5, and then it's going to be 7, and then 7.5, and then 8. And that's the end of today's lesson.